Hi, my name is Kiran Baburaj, and today we are diving into binary search tree searching operation. Before we begin our search, let's examine our binary search tree. Notice that hierarchical structure with 50 as our root node. Each left subtree contains smaller values while right subtree contains larger ones. Let's begin with searching for 40. We start at the root node 50. Since 40 is less than 50, we move to the left child, which is 30. Now we compare 40 with 30. Since 40 is greater than 30, we traverse to the right node 40. Match is found. Our search completed successfully at this node. Total of 3 comparisons are made, demonstrating the order of log n efficiency for the balanced binary search tree. Now let's search for 55. Again start at the root node 50. 55 is greater than 50, so we move right to node 70. Comparing 55 with 70, since 55 is smaller, we go to left node 60. Now at the node 60, 55 is less than 60, but there is no left child available. This termination at the leaf node means 55 is not present in our tree. Now we will explore the Python code that makes the search possible. Let's start by examining the search method. The search method takes a key as input and checks if it exists in the tree. First, it checks the current node's key, matches the search key. If it does, we have found our value. If there is a match, the method returns true. If the search key is smaller than the current node's key and a left child exists, we move to the left subtree. Here the method calls itself recursively on the left child, continuing the search. Similarly, if the search key is larger and a right child exists, we move to the right subtree. Again the method calls itself recursively, this time on the right child. If we reach a point where no child exists to continue the search, the method returns false, indicating the key isn't in the tree. So what we have learned today? The search method uses recursion to traverse the tree, and it compares the search key with each node and moves left or right accordingly. The time complexity is in order of log n in balanced tree. I hope you enjoyed the video. Don't forget to like the video. Subscribe for more videos on DSA. Happy coding. Thank you.